can see, okay, we have two functions given. First we have price function, the second we have cost function. Okay, so the solution for A, okay, determine the weekly revenue Rx. So we know that, okay, the formula for Rx is, okay, price multiplied by the quantity. Okay, so our price just now, we have the function negative x square plus 15x, and multiplied by x, we get negative x cube plus 15x square. Okay, so this is the solution for A. And then for B, how many dresses should be made and sold per week in order to maximize the revenue? So the keyword here is maximize. Okay, when maximize, you can see that it will be the at highest point. Okay, and the question is, should we use relative extremum or absolute maximum? For me, I will use here. Okay, imagine this is the graph of profit, the graph of revenue. Okay, the graph will be fluctuate, right, according to the month. Maybe this is January, this is February, March, April. Okay, so same goes to the, maybe this is, okay, this is about the revenue for each month. Okay, we change to the number of, okay, maybe number of units sold. Okay, we can change as, okay, number of units sold. So here we can see that we have two absolute, okay, we have two maximum points. So which one we want to take? So I will use here absolute maximum. Alright, so the steps like you learn in 2.15. Okay, first, okay, we have here the revenue function, and then we differentiate, we get negative 3x squared plus 30x, and then we set r prime x equal to 0. We get here, okay, the value of x, okay, negative 3x squared plus 30x equal to 0, and then factorize, we get, okay, I put outside 3x, and then in bracket negative x plus 10 equal to 0. So here we have 3x equal to 0, x equal to 0, and then the other part, negative x plus 10 equal to 0, and we have here negative x equal to negative 10, x equal to 10. So here we have two critical points. Okay, and then we substitute into the function of r. So here we get 0 for critical point number 1, 0, and then for critical point 10, we get 500. So we know that, okay, we have the highest point, okay, the highest peak is equal to, the highest point of revenue is equal to 500. Okay, so this is okay, we have 2 points, right? So 500. Okay, no number of dresses should be made, so means that the dresses should be 10 dresses lah, because of we have the highest point, the highest revenue is at RM 500 ringgit. Okay, so this is point B. Okay, then point C. Okay, what is the price per unit? Okay, what is the price per unit in order to maximize the revenue? So price per unit, just now we have 500, right? So 500 divided by 10, we get RM 50 per unit in order to maximize the revenue. Okay, this is point C. Point D, find the R prime 2, okay, and interpret. So right now we substitute the value. Okay, just now we already differentiate the R, so now we substitute the value of 2, and then we get we get RM 48. So what does it mean by 48? We know that when we differentiate the revenue, we get either marginal cost, rate of change, and also one more approximate value for the next item. So we know that, okay, how to interpret this. Okay, let's say if we do for number 2, okay, quantity 2, now we are actually approximate, okay, the approximate revenue of selling the third item is RM 48 ringgit. Okay, so this is answer for D. And then for E, okay, what is the profit function? Okay, profit function, we know that profit is equal to revenue minus cost. Okay, so our revenue just now, negative x cubed plus 15x square, minus with our cost, 10,000 plus 3x. So we have here negative x cubed plus 15x square, and then minus 3x minus 10,000. Okay, so this is answer for E. answer for F. Okay, what is the actual cost for the 11th unit? So you remember that my formula just now, Cx minus 1, right? So meaning that the 11th item minus with the 10th item, so we get here, just substitute the value of quantity of 11 into cost function, we get 10,330 minus 10,300. So we have here Rm 30 ringgit. Okay, for the 11th item, the cost is Rm 30 ringgit. Okay, now we proceed with the answer for G. Okay, G, we have here the function. Okay, P equal to 1,000 minus X. What is the level of production in, is the revenue increasing? They ask for the interval actually. Okay, so when we look, we have increasing, you have to apply 2.11. Okay, so when we talk about revenue, so you have to apply the formula R equal to Px. Okay, and then you have to substitute the value of P into X. We have here 1,000 minus X multiplied by X. We get 1,000X minus X square. So our domain right now, okay, X cannot be 0 actually, class. Okay, so X must be greater than 0. X must be greater than 0. Okay. Okay, now we apply topic 2.11. Okay, differentiate R, we get 1,000 minus 2x. So we now find the critical values. Okay, set R prime equal to 0, we get the first critical point is equal to 500, and the other part is for undefined is none. So from here we do our table. Okay, so our interval just now, we have 2, 0 up to 500, and 500 up to infinity. Okay, so our test point is x equal to 150, and the other one x equal to 800. When we substitute into the function of R that already differentiate, we get the positive value and negative value. So we have here one increasing and one decrease. So we know that the question asks you for the interval where the revenue increasing. We have here, okay, so the increasing interval is from 0 to 500. Okay, the product, okay, that's all for number 8.